Assalamu alaikum, ladies and gentlemen, welcome back to another live stream. So this is part 3 of my series of trying to learn SDL3 GPU, of course with the latest C++ version, C++23, and of course Modern CMake. Alright, let's get going. So this is, well, hold on, let me share the link in my Discord server. Please join my Discord server. You can find the link down in the description below if you're interested to get pinged every time new stream is on live. And there we go. By the way, if you find the pings annoying, then you could just like go here and then mute the channel or do notification settings and so on. But yeah, other than that, there we go. Hello, Lupin Luminary. Welcome back to the live stream. How's it going, man? Yeah, let's go. Alright, so this is what we got in the previous stream. And let me grab the chat real quick. Pop out the chat. Let's go. Alright. So this is what we got in the previous stream. Of course, all this code is in the link in the description below. We have made everything, or at least almost everything, in stream. So yeah, so right now we just have this cube, textured cube, rotating, and that's basically what we got. Today I'm gonna try to actually load a mesh. So how are we gonna do this? We're gonna use a library called Assimp. So Assimp C++. There we go. So we're gonna be using this library, which actually is like could basically import a lot of a lot of object formats. So it's a library that loads various 3D file formats into a shared in-memory format. It supports more than 40 file formats for import and growing selection of file formats for export. So even export. Though it's kind of heavy, honestly, because, well, it supports all of those formats. Though if you really want to, you could just like change some CMake variables to actually disable the formats that you don't need in your own engine, basically. For now, we're not going to bother with that. We're just going to install this library and start using it. So let's get going. All right, so in my CMake list here, if you want to understand my CMake setup, you could watch my previous streams and my latest video about Modern CMake. Other than that, it's pretty simple to add a new library. Just say Assimp, and here the AI already figured out what to do here. So gh assimp, and then I'm just gonna copy the latest commit that I want to clone, and then I'm gonna paste it here. And then of course I'm gonna stop and reload my CMake real quick. Oh, I forgot one thing. We also wanna list append libs assimp to add it, to link it to our executable here. And that should be it. The next thing is that we're gonna need some mesh, right, with its own texture. Now, at least for today, we're probably not gonna bother with like multiple mesh faces, you know, with multiple textures and so on, and like a scene and so on. Nah, we're just gonna take a mesh, right, and we're gonna like take all the vertices of all the faces, put them in a vertex buffer, and, you know, just display them as a mesh and using one texture basically. So I'm gonna use Vulkan Tutorials mesh. I think that's great. Load in models here. So here they have a sample mesh of a Viking room. So like if you actually come here, Viking room.obj, I'm gonna save as, and then you could save it to wherever you want. I could save it here in my desktop, and there we go. Though, okay, well, hold on, it shouldn't be txt file, it should be obj. So desktop, oops, oh my god, obj. As you can see, I already have it, so I don't need that. And the same thing with the texture, you also need this one. So just save image as, and then, you know, save it in wherever you want. Okay, cool. Now I'm just gonna go to my desktop real quick and grab those files. So desktop, okay, there's a lot of crap here. Hello Theo Paris, welcome to the live stream. Actually, you know what I'm gonna do? I'm just gonna come here. open in Explorer, and then I'm gonna copy this link here, and then I'm just gonna save image as and save a new image there, pretty much. And I'm gonna call this Viking room, okay? .png. Perfect. Same thing here. I'm gonna save as, and then instead of content, I'm gonna make a new folder called models. Well, I've already done so. And then I'm gonna put it there, and of course it should be obj file, not txt. And there we go, we're done. Cool, lovely. Now let's actually start doing this stuff. So what we're gonna need first of all is an Assimp importer, where I'm gonna create this. Let's see, we could, I guess, do it here. Sure, why not? So Assimp importer, well, Assimp importer, and then I'm gonna tab so it can actually import the declared header, basically. There we go, importer. And now I'm gonna make a new scene, or I'm gonna read a file, right? Content models, instead of cube.obj, I have Viking room.obj. And now here we have this flag right here, which include async post process, yeah. Alt enter to import that. Oops, what the heck, bro? Alt enter. Okay, there we go. Cool, love that. And next up, we're gonna make sure that the scene have loaded successfully. And oh, one little thing is that since we haven't fixed that copying assets thing yet, what we need to do, since we actually modified our content folder, which gets copied to the output directory, we should make sure to, every time we change that content folder, to reload our CMake to make sure that it actually goes ahead and copied the content folder. Other than that, it wouldn't work, so yeah. Alright, so I think that's basically it. Right now, what I'm gonna do, instead of having these vertices like this, you know, inline, I'm just gonna have like vertices and then a vector for indices, and then I'm gonna go through all the meshes in the scene. So there we go, for all the meshes in the scene. We don't need a 0 here. For I is less than scene is incomplete. Include Assimp scene, sure. So scene and meshes, so we're gonna go through the first, no. Let's go through all the meshes, please. So let's say m meshes, m number of meshes, okay? So we're gonna go through all the meshes in the scene. There we go, cool. So through all the meshes in the scene, so as you can see, const auto mesh, size g, number of vertices, and well, yeah, we're gonna go through all the vertices in those meshes, right? We're gonna construct a vertex here, and this kind of sucks. Dot position is equal to glm. This is stupid. I don't know why the AI did this. It's annoying. Anyways, let's see if it works now. Cool, perfect. That's what I'm talking about. Dot uv and dot. No, we don't need any color. Just position and uv is what we need right now. Vertices dot pushback vertex. Perfect. And in fact, I think we could probably just inline this here. And we don't need that. Perfect. Okay, cool. Let me just make sure that this is correct. So here we're basically getting the vertex, right? I mean, to make it even more clear, we could say const auto vertex, right? And instead of this, we could just say vertex.x, vertex.y, vertex.z. Here mesh texture chords. Otherwise, okay, it's checking to make sure if it's not null or if it's null. Let's see. Okay, that's perfect, cool. And of course here we're going through, like after we're done with the vertices, we need the indices, and we are gonna get the indices from the faces. So we're gonna loop through all the faces, right? And then we're gonna loop through all the indices in those faces, and then we're gonna push them back into the indices buffer. And then of course the other code would do the rest, and that's basically how it's done. That's basically how it's done. And for the texture, we're gonna change it to the Viking room. So instead of screenshot.png, which we had before, we're gonna use Viking room.png here. Okay. Now it would be more advanced in the future, but for now this should work. Okay, and we should have a Viking room floating around the scene. It's gonna take some time, as I said, though we could probably look into the CMake variables and like disable stuff that we don't need. So like if we go to CMake here, oops, CMake, let's see, color scheme, CMake, there we go. Okay, so as you can see, there's quite a lot of variables here about Assimp. Assimp Android. Yeah, where's the Assimp variables for formats? I don't see it here. Oh, there we go. Build all exporters by default. So you probably want to turn these off and then enable the formats that you want to manually, I think. That's weird. Let me check it out actually. Well, anyways, it's actually done compiling. Alright, let's see if this works. And there we go. We got our Viking room on. It's really that simple. And in fact, it doesn't have to be like an OBJ file. It could be an FBX, a blend file, whatever, you name it. And there we go, we got it. Now, I'm not entirely sure what I'm gonna work on next, honestly. I think one thing that I have in mind right now, which is very simple to implement, which is like MSAA. So let's go ahead and implement that. And by the way, please go to my GitHub repo for this project and like leave a star if you haven't already, so we can reach to more people, especially the ones that needs such examples. So github.com, right, Kodotaku game engine. Just leave a star here, and thank you. All right, so. Okay, let's go to the SDL examples right now. SDL examples. Well, SDL GPU examples, right? And in fact, let me push this commit first of all, right? Lloydine meshes. Commit and push. Sure, push it, why not? Alright, and there we go. Okay, cool. Now let's go to the examples and let's go to the MSAA example. I haven't checked it out yet on my own, so I'm gonna check this live. Hopefully nothing crazy. It should be the same as Vulkan, just a little bit simpler probably. But yeah, alright, let's see what we got. Alright, so I do see some stuff going on here. GPU, so support some. First of all, it's checking for the support that is there, like for how much MSAA samples are available in the specific GPU. Okay. And then it's enabling it in the pipeline. And then it's creating a render target for it. Oh yeah. Well, one thing for sure that I want to do actually is, let's see, where's the resize thing? Resize event. Yeah, so these things right here, I want to make them into their own function, honestly. Well, or you know what? Never mind. Let's just keep going, okay? Alright, whichever. Let's go first of all to the pipeline right now. Let's go to the pipeline. I'm trying to resist the urge of actually starting to like abstract this stuff, because the more abstract, like the more we're gonna waste time and the more things would be harder to change and so on. So yeah. Anyways, let's see what we got here. Dot samples. Okay, so there's a multi-sample state here, and sample count is equal to. Alright, so what this kind of sample count is, SDL GPU multi-sample count, huh? Or maybe sample, okay, there's a sample count. Let's go with 8, why not? And now what's next? Well, ideally we would need to check for the actual supported samples, but let's just ignore that for now. We do get a need to create a GPU texture for the multi-sampling thing, apparently. And we have to make it into sample count. So actually what I'm gonna do here, I think, is have like an integer MSAA count equal to, let's say, well, actually no, what the heck I'm saying. There we go, sample count 8. Alright, there we go. MSAA count. Does that make sense? MSAA sample count, sure. And, well, not integer, really. There we go. Cool. Now, what I'm gonna do is use this here. And now I'm also gonna create the texture, basically. Here I'm creating the depth stencil texture. Now let's actually create the MSAA texture. Let's see if the AI could figure this out on its own. Perfect. Window width, window height. And here, most importantly, the sample count should be MSAA sample count. I do think that depth stencil texture should probably be the same way too, maybe. If I remember, at least in Vulkan it was. But I guess we'll just have to find out on our own. Alright, anyways, and after that, we gotta create that texture. And we gotta make sure that it's actually on, and why not name it? No, what the heck it's doing there? Give it a name, dude. Set GPU texture name. Okay, give it a name, please. Come on. There we go. Perfect. Cool. Now that we got MSA texture, we need to actually use it somewhere. Let's see. Texture create info usage. SDL GPU texture usage sampler, huh? Usage. Usage, is there usage here? Yeah. So I probably need to add this. No? I guess we'll find out anyways. Alright, what's next? Create a resolve texture. Alrighty, this is crazy. Create a resolve texture. Alright, whichever, go on. Dot texture, MSAA render textures. Okay, and then what? Store OP store. I see. So it could be sample count 1, and if it's the case, then we gotta do something about it. I see. Alright, whichever. Dot store OP resolve. And resolve texture. Alright, so let's go to where we're doing the render path stuff. Where's the render? There we go. Okay. So instead of the swap chain texture, what we gotta do is use the MSAA texture instead. So basically render into the MSAA texture. And then we want to use a store store op is equal to SDL GPU store op resolve, right? And then we want to give it the resolve texture, which is the actual swap chain texture. So we want to render into the MSAA texture, which is like a transient texture. And then we want to resolve it into the swap chain. Perfect. But yeah, we're probably gonna need an MSAA texture for depth too, maybe. But for now, this should maybe work, possibly. I guess we'll have to find out. Is there anything else? I don't think so. Let's see. Let's see what's gonna happen. If there's anything, there's gonna be an error. Oh my god, this declaration order thing is really annoying. Really annoying. So it should come before the depth stencil apparently. That's why. And let's add that. And there we go. Let's try now. And yeah, we have an error apparently here. Let's see what the error is. Of course, it's Vulkan errors, but I do understand Vulkan, so hopefully I can understand this. So depth stencil, yeah, it's talking about the depth stencil that it doesn't have enough samples. So we need a depth MSAA texture too. Yeah, I was right. All right, sure. I'm glad I've gone through the Vulkan stuff. Anyways, depth stencil texture. All right, so MSAA depth stencil texture. Let's see if the AI could figure this out. Shouldn't be that hard. Ah, what the heck? No, bro, what the SDL? Oh, what? No. No. SDL GPU texture create info. There we go, cool, love that. And as you can see, sample count, MSAA sample count, and then auto, MSAA depth stencil texture, and we check to make sure that it's got created. And now we could hopefully use it. And by the way, let's actually name these things. So let's name this depth stencil texture. And let's name this one too. SDL MSAA depth stencil texture. Perfect. Love that. All right, now let's actually use this MSAA depth stencil texture here. So instead of rendering into the depth texture directly, again, the same thing we've done with the other one. Here, I think, yeah. So instead of depth stencil texture, we're gonna render into MSAA depth stencil texture. So the multi-sample texture. And then we're gonna resolve into the actual texture. So store OP is equal to SDL GPU, store OP, resolve and store. And then, why there's no resolve texture here? What the heck? What? Hold on. What? Yikes, what? So maybe we don't want that. Huh, let's see. Okay, let's see what's gonna happen here. Maybe we don't need a second texture for depth. Maybe we just need one multi-sampled one. Yeah, apparently. Nice. Perfect. Okay, so we don't need that MSAA depth texture actually. Apparently. So let's just remove this. Right? And let's just keep only that one. Where is that one? That depth texture, there we go. Okay, and just instead of like, we're gonna need to add MSAA samples here. The sample count is equal to MSAA sample count, and that's basically it, I think. Alright, and then here let's just use the original texture. Where is it? There we go. Perfect. And then that should work out just fine. The one other thing is that we need to actually recreate the MSAA texture when the resizing happens. Otherwise, we're gonna have some funny things happening. So we release the old texture, and then we create a new one basically. So MSAA texture info width height, and then we basically create the thing. MSAA texture is equal to that. Perfect. And of course we gotta make sure that it got created successfully. If not, then do that. Alright, perfect. Now let's go into running this, and we should have MSAA now. And there we go, we have MSAA. So this geometry is way smoother now, which is cool. And in fact, if I open this into render doc, I can show you what MSAA does exactly. Let me see, models, shaders, build, bin. Okay, where is the binary? There we go, exe. And let's just copy the path reference, absolute path. Let's come, oh my god, my eyes. Okay, executable path, and then the working directory. The working directory, I mean, it's fine like that. And now let's launch this. Let's capture one frame here. And let's see what we got. Alright, so this is the Vulkan commands basically. And there we go. So here in our draw function, in our draw call, we're actually drawing 11,484 vertices, right? So here's the MSAA texture, here's the swap chain image, and here's the depth stencil texture. There we go. That's pretty sick. Alright, so the MSAA texture, as you can see, there's 8 samples there. And if you actually zoom in here, notice the ridges, right? It's very sharp. But if you come here in the swap chain image, where the MSAA texture got resolved into this one sampled or unisampled image, there we go, it got smoothed out, which really looks way smoother. So that's pretty sick. And of course we have one input, which is the actual Viking room texture here. And yeah, that's basically how it works. So yeah, guys, that was it for this stream. Thank you all for coming in, and see ya in the next one. Goodbye, everyone.